Hi everyone, welcome back to another episode of Genetic Codecast, where we decode science and turn it into a good coffee chat material. So, we've been reading your comments, and guess what? A bunch of you have been asking, can you guys please talk about genetics? Like, what even is a DNA? How does it work? And why do people say we all have genetic blueprint? Well, guess what? Your wish is granted because today we have something super exciting and a special guest all the way from Japan. Someone who actually knows their stuff when it comes to molecular biology. So, without further ado, let's welcome our very own special guest, Dr. Naomi, who is unfortunately joining us over an online meeting since she's on duty abroad.
Hi everyone, thank you so much for the warm welcome.
Thank you so much, Dr. Naomi, for sparing some time to talk with us. Okay, before we begin our talks today, can you please mention a bit about your background?
So, I specialize in DNA structure and genome stability, and it is honestly such a thrill to be here. I never pass up a chance to talk about the incredible molecule that defines who we are, which is DNA. So, I hope you are ready because we are going to unravel the double helix and dig into what makes us us.
Okay, it's nice to hear that. Let's dive right in. So, we hear about DNA all the time in school, on TV crime shows, or even in superhero origin stories. But at its core, what is actually a DNA and why is it so important in our lives?
I love that questions. So DNA, which stands for deoxyribonucleic acid, is essentially the instruction manual for life. It is the molecule that holds all the information your body needs to build, maintain, and repair itself just using four basic letters: A, T, G, and C. These four letters create the code that makes you, me, and all living things.
Okay, so that's honestly so cool. It's wild to think that something as tiny as those four letters can control so much. Alright, now that we have got a handle on what DNA is, let's zoom in a little closer and talk about something more specific, something that we see in everyday life, which is genes and traits. Before that, let me ask you a question. Have you ever looked at your parents, then at yourself, and thought, hey, I've got my mom's eyes, or maybe that's definitely my dad's smile? Well, that's not just a coincidence, and it's actually the result of something deeper going inside your cells. So, Dr. Naomi, can you explain how genes are responsible for these kinds of similarities?
Absolutely. So those family resemblance you notice like facial features, hair texture, or even the way you laugh, they all come down to genes. And genes are made up of DNA and they carry the instructions that determine your traits and pass it down from your parents to you. So when you say, I got my mom's eyes, you are actually pointing out the expression of a gene that was inherited from her.
Oh, wow, that's very incredible. So, our features are basically like little gifts from our parents wrapped up inside our genes. But here's something I've always wondered. Why do some traits show up clearly, like dark hair or dimples, while others seem to skip a generation or like stay hidden?
So that all comes down to something called dominant and recessive traits. A dominant trait is one that shows up even if you only inherit it from one parent, which is the more visible one. And on the other hand, a recessive trait stays hidden unless you get it from both parents. So, for example, brown eyes are typically dominant over blue eyes. If one parent gives you a brown eye gene and the other gives you a blue eye gene, your eyes will most likely be brown. It's like a little game of genetic tug of war, and the dominant one usually wins.
Alright, so dominant traits usually take the spotlight, and recessive ones hide in the background unless both parents contribute them. Okay, I understand and got it. Now, let's take it one step further. How exactly do we get these genes from our parents? Like, what's the actual process behind it?
Well, that brings us to chromosomes. Humans have 23 pairs of chromosomes, and that is 46 in total. You get half of them from your mother and the other half from your father. Each chromosome carries hundreds to thousands of genes, and when the egg and sperm meet, they bring together one set of chromosomes from each parent.
Oh, wait, so you're telling me I've basically been walking around all these years as a giant bundle of 23 mom and dad mashups? Now it makes sense why I got my dad's hair but not my mom's clear skin. DNA really said mix and match. But hold on, not all traits are just about appearances, right? Some genes can carry hidden risks too, especially the ones that doesn't show up unless you inherit them from both parents. So Dr. Naomi, can you please tell us more about these recessive genes and what the actual meaning for our health?
So this is where the things get really interesting. And now let's talk about recessive genes. They often get called the quiet ones because they don't show up unless you get two copies, one from each parent. Mm, and some people even think of them as the weaker gene, but that is not quite right. It is more accurate to say that recessive genes are hidden by dominant ones when both are present. So you could be carrying a recessive gene without even knowing it, and that gene may not affect you at all, but it can still be passed on.
Wait, so you're saying that I could have a recessive gene just chilling in my DNA and never know it unless I pass it on? Wow, so that's kind of wild to know. So, how does that actually work? Like, what needs to happen for a recessive gene or a recessive trait or even a genetic condition to actually show up?
So, this is where the inheritance patterns come into play. Let's say both parents are carriers of recessive genes, and this means that they each have one dominant and one recessive copy. When they have a child, there are three possible combinations that can happen. So there's a 25% chance that the children will inherit two dominant genes, which mean that they just being normal. And then there's also a 50% chance that the child will inherit one dominant and one recessive gene, just like their parents. And this means that they are a carrier. And lastly, there's a 25% chance that the child will inherit two recessive genes. And this is when the recessive trait or condition will actually shows up. You will often see this visualized in something called a Punnett square, where lowercase letters usually mark the recessive condition.
Okay, wow. So, even if both parents are totally healthy, there's still a chance that their child could inherit a recessive condition if they are both carriers. Wow, that's actually kind of mind blowing, honestly. Can you give us some real life examples of conditions that we can say like that works this way?
Alright, so there are several well known genetic disorders that are inherited in our recessive patterns, meaning that you need to get two copies of the faulty gene for the condition to actually show up. And the common examples are cystic fibrosis, sickle cell anemia, and also thalassemia.
Well, that was seriously eye opening. From dominant and recessive traits to hidden genetic risks. There's just so much happening behind the scenes in our DNA. And huge thanks to you, Dr. Naomi, for breaking it all down so clearly and making it actually fun to learn about these genes.
It was such a pleasure. Thank you for having me. And remember, our DNA might not be visible, but its impact is massive.
Alright, so after this advertisement break, we're going to bring you guys in someone really special, someone who's actually living with a recessive genetic condition, and they'll be sharing what it's like with life beyond the biology, the challenges, their resilience, and how knowing their genetics changed their life. So stick around and be sure that you don't want to miss it.
One eternity later.
Hi guys, welcome back. So previously we talked about recessive genes and how traits get passed down and also the science behind genetic condition. But now, as promised, this segment is something really special because we're inviting someone who's living proof that genetic isn't just a textbook stuff. So today I'm joined by someone incredible who lives with a recessive genetic condition and they're here to share their story. the ups and the downs, and how understanding their DNA has shaped their journey in a powerful way. Here we have Morgan. To start things off, can you please share what living with a recessive genetic condition has been like to you?
Okay, so hi. Hi, my name is Morgan. So, hi, thank you so much for having me. I'm really happy to be here. So, a little bit about me. I was diagnosed with beta thalassemia when I was a child, which is a recessive genetic condition, which means I inherited from both of my parents, even though neither of them had any symptoms, but they were just carriers.
Okay, thank you so much for sharing that. It's honestly really powerful to hear it directly from someone who has living with it, not just studying it in a classroom. And it's kind of wild to think that your parents had no idea when they were carriers, right? Like they had no symptoms at all, and yet the genes they passed down had such a big impact on you. How did you and your family find out about the diagnosis? Was it like sudden or something that came up over time?
So, yeah, it was definitely a surprise for my family, especially since my parents don't really have those symptoms. I was around 2 years old when my parents first noticed that something was off. I was getting really tired really easily, and I looked pale all the time, and I was just getting more sick than usual. So at first, they thought it was just a regular childhood thing where every single kid goes through this. But after a few tests and referrals, the doctor finally diagnosed me with beta thalassemia. So that's when we actually learned it was a genetic condition, and both my parents were completely shocked to find out they were carriers. They had no symptoms, nothing to indicate it at all, and I think one of the hardest parts about that at first is probably just the guilt that they felt, even though it wasn't anyone's fault and I'm not blaming them at all. But once we understood what it was and we started learning how to manage it, like regular blood transfusions, monitoring my iron levels, and just being really mindful about my health, especially with my immune system, that's just how we kind of deal with that.
Oh wow, that must have been a lot for your family to take in, and especially that it happened so early in your life. So, how has it been growing up with beta thalassemia? Like, what's the day to day routine life like for you now?
Well, at the start, it definitely wasn't been easy since I was still a little child, but it has become a part of my routine since I've grown to it. So I get blood transfusions every few weeks or so, and I have to watch my iron levels closely because of that. There are days where I feel totally normal, like just a regular person, and other times when I get really tired or have to miss out on things. But I've learned to listen to my body, pace myself, and not to be afraid to ask support when I actually need it. Honestly, understanding the condition has helped me feel more in control of it. Like, it's a part of me, but it's not what defines me.
Okay, so before we wrapped up our session today, and last but not least, for everyone listening who might be a carrier or just curious about their own genetic health, what is something you wish more people can understand about recessive conditions? And is there anything you'd recommend, like resources or steps that they could take?
So, I'm assuming that everyone who's watching this, um, as this is about recessive genes, so not everyone that looks healthy is actually free of any disease. So, when someone actually looks healthy and they do their normal life day to day basis, it doesn't mean that they're not dealing with something invisible. And recessive genetic conditions are real, even if you can't see them. That's why awareness matters, from like campaigns or videos or infographics that you can see. Tools like genetic counseling and testing, which are now available in many clinics, which I'm very glad for, can really help people understand their risk and make informed choices. I even know a couple who used testing to discover they were both carriers, and thanks to that, they were able to prevent passing the condition on to their children. And that kind of knowledge is very powerful, especially for the future generations.
Okay, thank you so much for sharing your story and your strengths with us today. And to all of our listeners, if this episode got you thinking about your own genetics or your family's health, don't be afraid to ask questions, explore genetic counseling, and or just start a simple conversation with people around you. So, this has been the Genetic Codecast, where we decode the science and the stories behind your DNA. We'll catch you on the next episode, and until then, take care and stay curious.
Goodbye, everyone.